One of the most interesting developments in the container space is this idea of the service mesh, which lets you join software components together and control how they communicate at a centralized level outside of the components themselves. And that unlocks powerful patterns like canary deployments, dock launches, encryption in transit, access control, and monitoring, all without changing your application code or configuration. Linkerd is a service mesh. A component will let you take control of the network communication between your application services. You can manage traffic routing, security, and telemetry centrally without changing code or configuration. Welcome to the CloudNative.fm podcast. Today on the CloudNative.fm podcast, we talk about Linkerd and the larger service mesh space with William Morgan, Chief Email Outputter and CEO of Buoyant. We cover William's thoughts around important concerns such as latency and cost, both in your cloud bill and in real human cost of operating services. And we talk a bit about the birth and evolution of Linkerd, including some of the design decisions such as Rust in the data plane and Co in the control plane while building Linkerd. And finally, we will talk about the importance of security with service meshes and how it should be reasoned. So if you want to know what he is up to, follow him on Twitter, William Morgan @WM. And let's go ahead, say hi to William and get it over to the interview. You are listening to the Cloud Native FM podcast, episode number 17. And we are talking about service meshes and more specifically diving into Linkerd with William Morgan, Chief Email Outputter, I like his title, and also a CEO of Buoyant. Hi, my name is Saim Safdar. I am your co-host for Cloud Native FM podcast. As I mentioned today on the podcast, we are talking with William. William is the Chief Email Outputter and also a CEO of Buoyant, who is one of the leading manufacturers of a service mesh called Linkerd. Linkerd, according to CNCF survey, has a market share of about 41%. And today we are going to dive into some of the details of Linkerd. We are going to talk a bit about service mesh Linkerd and also the larger service mesh spaces. And we will talk about William thoughts around important concerns that deal with things like latency, cost, both in cloud service bills and also in the human cost involved operating these services. And we will also talk a bit about a design pattern, birth and evolution of Linkerd. Linkerd uses Rust in the data plane, Go in the control plane. We will talk a bit about why that is and some of the design decisions made along the way. And we will also talk about the importance of security and zero trust configuration as we leverage service mesh and how to run a successful business from service mesh. That is the most important agenda of the today talk. So, William, welcome to the podcast. How are you? Can you introduce yourself to our audiences? And what are you doing these days? And how much time you spend home with Linkerd?
Hi, Simon. Thank you for that very nice introduction. It's great to be here. So I'm William Morgan. Like Simon said, I'm the chief email outputter of a company called Buoyant. Buoyant was the creator of Linkerd. Linkerd now, of course, is a CNCF project, so the CNCF kind of hosts it and so on. But Buoyant as a company invests most of its time in like maintaining and supporting Linkerd. And then we also have a kind of a SaaS product that's half under wraps called Buoyant Cloud that allows you to run Linkerd at scale across multiple clusters with a really nice pane of glass. So I encourage you, if you are a Linkerd user, please check out Buoyant Cloud and let us know what you think. But it's really great to be here. Thanks for that lovely introduction. And I think you asked, how much time do I spend on Linkerd? So, I'd say me personally, I actually don't write code anymore. I used to be an engineer, but now I have ascended into the lofty position of the person who does a lot of speaking about Linkerd, a lot of writing about Linkerd, and so I'm kind of like I do a lot of talking about it, and I spend a lot of my day talking about it. But not writing code directly.
Yes, I see William is a person who did podcasts and help people adopt service meshes. Why do they choose one? What it brings to you? The William is a person who help you understand what the service mesh is and what it needs to offer. And next question to William, that's very interesting. How much COVID affect your traveling? And did you enjoy working from home or still praying for days that you one day work from office?
Yeah, that's a really good question. So how did COVID, affect us? I thought it would be a lot worse than it is. So I think we had a little bit of an advantage at Buoyant in that we had already been hiring kind of remote folks and hiring, in some cases, international remote, especially on the open source side. The work around Linkerd is very conducive to that. It's happening over GitHub, it's happening over GitHub issues and PRs and stuff. So it's kind of naturally asynchronous. So that part of it was kind of okay, and in fact, it was kind of nice because it leveled the playing field a bit. So, the folks we had who were in different parts of the world and not in like the SF office, we're now on the same footing as people who used to be in the office and now we're kind of zooming in from home. So, I thought it was going to be bad, but actually it turned out to be kind of okay. And we actually made the call at Buoyant I'd say about a year ago. We said, this is working. I don't know what's going to happen with COVID, but this is working well enough for us that we're going to become a remote first company. And we're actually going to get rid of our office space. And this is how we're going to work together going forward. And that actually has been very liberating because it's allowed us to hire people from all over the world. And like I said, everyone is on the same footing because we're all sitting in front of a screen, coming to a meeting through Zoom or whatever it is.
Yeah, definitely. I think I see people talking about the remote part of it. The COVID effect is very negatively, and some part of it as a positively because around the world you gather talent from the different part of the world. You hire your team remotely, whichever their room is sitting in, and uses their mind and energy to build an awesome open source tool. I think that's the way the COVID affect us as well positively as well. And I see,
Right. Yeah.
I see.
So,
Also, you are at. I think you before the Buoyant and Linkerd. I think you are from. You spent some time with Twitter as well. So can you tell our audience what your experience was at Twitter and what happened when you tweet someone? What happened behind the scene? What are the good people behind the scene there?
yeah. So yes, I was at Twitter I wouldn't say the very early days, but kind of the medium early days. I was there from 2010 to 2014. And what was really interesting, I had had a bunch of kind of startup jobs, all software engineering, before that. And at Twitter, I came in as an engineer and I eventually became an engineering manager. But what was really interesting about Twitter at that time, in that time period, was when I started, it was, we had this monolithic Ruby on Rails app that powered basically all of Twitter. And it was just not really working. It was, at the very tail end of its ability to scale. There were a lot of other factors involved, and in part because Twitter is just this kind of a very naturally asynchronous set of workloads. You'll have one person who has 100 million followers or whatever it is, so they make one tweet, and all of a sudden 100 million things have to be affected very, very rapidly. So it's a hard application to run in the first place, and that Ruby on Rails monolith. It was having a hard time scaling. And I was a big Ruby fan. So I was like, well, I think we should keep investing in Ruby. But, they made the call to break it up into microservices, and then the next 5 years or whatever were spent basically rebuilding that monolith as microservices, mostly written in Scala, sometimes in Java. So running on the JVM, running in this thing called Mesos that I had never heard of and sounded crazy, but I guess, it kind of worked. And building up a lot of the infrastructure that was necessary to make that big microservices system work at scale. We didn't actually even call it microservices. We didn't have that word. Like we called it SOA. We didn't really know what else to call it. And then a lot of the, kind of the impetus for Linkerd and the things that we decided, had to be brought out to the world came from that experience and came from some of the Twitter open source projects that had been built in order to power that big microservices architecture. There's a library called Finagle that we used, and the first version of Linkerd was actually just like a wrapper on top of Finagle. So a lot of the kind of service mesh history is embedded in that story of Twitter moving from monolithic Ruby on Rails app to this big microservices app architecture running on Mesos in a distributed environment and so on.
Yes, I see a talk from, I think it's 2017 or 2016. You did this to I think it's a KubeCon talk or at some else talk there. And you talking about the Twitter, what is the Twitter full open stack, what is built on it. So it's kind of interesting. So finally I know how Twitter is built and what happened by tweet, what language it uses. So that's a really interesting story. When I first heard your talk, I think it's a KubeCon 2016 or 2017, and you did all kind of talk. And then I think I know what the Linkerd is, what the Finagle is, and how it's originated.
Right. Now, who knows what Twitter has done since then? That was like, I haven't been there for 7 years, so like it could be totally different now. And Linkerd itself, we've completely rewritten it, so we're no longer using any of the Twitter stuff. So the two kind of worlds have really diverged. But that was the origin, was that, very specific and kind of crazy moment in time when all this infrastructure work was happening. It was happening in kind of a public way. Everyone was aware of the Twitter fail whale. It was like this funny thing. Twitter, it's down again, right? And we don't really see that much anymore.
Yes. And the first question, I think I see people are explaining what the service mesh is, but I find it interesting to know, how do you define service mesh?
Yeah, this was actually a big challenge for us early on. Nowadays everyone has heard of a service mesh, and like maybe you don't really know what it is, but it's a thing, and you have to use it, or you probably should use it. But back in the early days of 3 years ago, not that long ago, but it feels like a long time, a lot of what we were doing was describing what this thing was and how you should think about it and why you needed to care. So the way that I like to describe it, I actually like to describe it in two different ways. I like to start with the value proposition, like why and kind of what it does, and then the implementation. Because if you start with the implementation, it just sounds crazy. So let me start with the value prop, which is a service mesh is a way of giving you these critical observability and reliability and security features in a way that embeds them at the platform level rather than at the application level. So the big kind of thing that the service mesh gives you is, rather than having developers implement TLS and try and do mutual TLS between services as a way of authenticating and providing confidentiality of the communication between services, you can just do that at the platform level. Okay, and rather than developers having to instrument every single service with a standard set of HTTP metrics or whatever, the service mesh can just do that for you at the platform level. And so the value is like, it's not a bunch of new features that we never had before. It's just we're giving them to you at the platform level rather than at the application level. So that's the kind of the value prop. And the next part of the answer is, okay, so how does it work? Like, what's the implementation? And the implementation is basically a lot of proxies. We take a lot of proxies, we stick them next to your application. The application ideally doesn't even know that they're there. And those proxies are, first of all, they're handling communication in between the components of the application, in between the microservices. They're recording metrics, or they're instrumenting the traffic, recording metrics, and like sending that off to be aggregated. They are doing things like mutual TLS. All of the service mesh features basically work by distributing these proxies. And that sounds crazy, and it was crazy, and Twitter didn't work that way, right? But the thing that makes it possible is basically the rise of containers and the rise of Kubernetes, because that makes it so that the deploy time challenge of, okay, I want to deploy 10,000 proxies and I want them next to the application, is actually something that's feasible, right? Before, if you were doing this by hand, right, or you were using Chef or something, you would never do this. That'd be crazy. Deploy 10,000 proxies. Don't want to do that. But with Kubernetes, you can kind of do it, and it's not that painful to you. And in fact, you can install Linkerd on Kubernetes in like 5 minutes, and it takes care of all the proxy stuff for you. So you don't even have to really care about the proxies. So that's a very long answer to a short question. What is a service mesh?
It's really explained a lot to me. And also, at the first time I heard about the Linkerd and the service mesh, I came up with this topic that you give a talk to, I think, Scott Hanselman on their Azure Friday, and you run it.
Yeah, that was a long time ago. Yeah.
Yes, 2019. And I see that you did one thing that I noticed from there, that a developer write a code, there's a multiple microservices involved in that. So you hit the front end talk to the database, and database talk to the cache, and these all kind of things. That's a 3-tier architecture. But the microservices architecture, there are 10,000 of microservices involved there. What happened when the one microservice is called to the another microservices, and the call is made by fail? So do this has the developer, if I give this responsibility a developer to find and trace that issue, I think it needed ages to solve these kind of issues. But with Linkerd, you take all kind of the developer code, and just at the platform, you told them that this is the microservices that hit the issue, go fix that. And that's where I really pin upon what is the value of service mesh there.
Yeah. And I think that's a good point. Like, it only makes sense if you're running microservices. If you're running a 3-tier architecture, adding a proxy, in front of tier number 2 doesn't really do a lot for you. Your first tier is probably a proxy already, so it only really makes sense if you are exploding that application out into lots of microservices. And then, this is what we learned at Twitter, is like, all of a sudden it was very different, right? We had all this new set of problems that we didn't have before. We had solved the scalability problem. Okay, that's great. But now we have this other set of problems. Okay, how do these services communicate with each other in a way that's resilient to failure, in a way that's secure, in a way that doesn't, drive the developers crazy?
Yeah. And next question, let's say that we are meeting in 2016, and let's time travel a bit and understand how people came up with this term called service mesh. And specifically, can you tell my audience, what's your initial set of goals with Linkerd first version? And I think it was the first service mesh incubated by CNCF, and who created this category in landscape in CNCF called service mesh.
Yeah, that's right. So we invented the term service mesh, and some days I feel very sad about that, because now it's a term that is associated with complexity, and I don't think it needs to be. And a lot of what we do with Linkerd today is try and fight against that and say, hey, the service mesh doesn't have to be complex. It actually can be quite simple. But so if we time travel back to 2016, that was the very first version of Linkerd that we made open source. It's like Linkerd 0.2 or something, and then later in 2017, we donated it to the CNCF, right? And it was the 5th project there. So it was like Kubernetes, Prometheus, something, Linkerd, so we felt great because we were up there next to Kubernetes. It was awesome. But prior to that, we had this challenge with Linkerd, which is we were trying to describe what it did, and we were trying to describe the deployment model and all this stuff. And so we had all these terms that made sense to us from Twitter. So I think we called it an application router. We were calling it an app router, and people didn't really understand that. And then we called it an RPC proxy, and people were like, well, I already have a proxy. And we were like, no, it's different. And they're like, well, we don't use RPC calls, we use HTTP. And we were like, okay, well, HTTP is actually a type of RPC, in our diagrams. And, eventually, people got bored and they wandered off. So we had a marketing challenge. We had to call this something. And so we ended up calling it a service mesh after experimenting with some other names, because it didn't have a lot of meaning, not really, right? What was a mesh? There was mesh networks, but it was different from that. And we were thinking about actually Service Fabric. I thought was a good name, but there was a Microsoft product called Service Fabric. So we're like, okay, that doesn't make sense. So we basically called it service mesh because it had no meaning. And what that allowed us to do was to say, and here's what a service mesh is, right? It was like a white space that we could then start filling in with what that means. And that term took off. And then suddenly, Linkerd was in this category, it had basically created this category, a thing called the service mesh. And then pretty soon you had Istio and Console Connect and all the other, projects, now there's 12 service meshes. So, I guess we created Linkerd and then we created this category that has other, other things in it.
Yes, I think a next question is really interesting to me to learn from you that in 2017 or later, Istio jumped into the service mesh market. And speaking of Istio, they are backed up with tech giants like Google, Lyft, IBM. And this kind of security for people, and can this give you the extra lift that you are moving in the right direction? But the story is that you are now competing with some giants like Google, IBM, and Lyft. What the initial thoughts was that in 2017?
I mean, we were terrified. It's like there was 5 of us, or something. It's like five people, and all of a sudden Google walks into the room. They're like, "We have a service," and we were like, "Well, gosh, do we want to? Should we just become like an Istio company? Should we abandon Linkerd? Should we become an Istio?" And we had some early conversations with the Google engineers, and they were very friendly. And the other thing that was scary, I think, for us was, it wasn't like IBM, or like some. I mean, it was IBM, but if it was just IBM, I wouldn't be that worried, right? Like IBM, okay, big company. Hey, it's like who you want to compete against as a startup. But it was Google. And Google just invented Kubernetes, and Kubernetes had dominated the marketplace, and everyone that we were talking to was using Kubernetes. So that was scary, it's, to go up against, and people were like, oh, well, Istio is going to be the next Kubernetes. But, and then finally, the final thing that was scary was that Istio at that point was actually a lot better than Linkerd. It was a lot better because Linkerd was on the JVM. It was using, the Twitter stack, which was awesome, Finagle and Netty and the JVM and Scala and all that stuff. But all of that stuff was designed to scale up, right? It was designed so that you could have one process, crazy amounts of traffic. And we were asking Linkerd to scale down. We were saying, we want you to be this tiny little proxy because we're actually going to, deploy 1,000 of you. And the JVM was not really able to do that. We did a bunch of engineering. We got it down to 150 meg, of runtime memory. And for some people that was okay, for people who were running these 3 gig JVM, but a lot of people who were adopting Kubernetes were running these 50 meg Go processes. And so for us to say, oh, you've got this 50 meg process, here, put this tiny little 150 meg proxy next to it, right? It's that's, and so that was scary too. So we were like, okay, we really have to think this through. Do we want to just jump on the bandwagon on this, or do we want to compete with it? And we ended up saying, we liked about Istio, but there was a lot we really didn't like. It felt like we could do something. I don't want to say better, but it felt like we could do something that was simpler. It felt like we could do something that was more future facing. Istio. So I won't get too much into it, but basically, after goal searching, we're like, I think we can actually do something that's a lot better here, and so we started basically rewriting Linkerd, and that was also scary.
Yes.
ADM, we can't. That's not going to be the future, not for Linkerd. So let's take a step back and let's think: what if we do, what if we could do anything? What's the ideal architecture? What's the ideal everything? And so, as you said in the very beginning, we ended up with Go on the control plane and then Rust on the data plane. And we started investing a lot of time in making the proxy super small, super lightweight, super fast. To our mind, the way this was going to work was you're going to have 10,000 proxies. Those proxies are 100 megs versus 10 megs. Big difference in your resource allocation. And if those proxies add 100 milliseconds of latency versus 10 milliseconds of latency, that's a big, big difference. Said, okay, control plane is going to be pretty standard, but that proxy really, something really fast, really small. And then the other, that was really on our minds at that time was something that's secure, right? Because the control plane sits off to the side, but the data plane, that's where your customer data is going through. That's where your PCI data, your HIPAA, personal information, people's healthcare records, monetary transactions are going through the proxy. The thing has to be. And so even at that point in time, which was like, this is now 2017, when we're like going through this mental exercise, we didn't want to write it in C or C++ because of that was kind of like the impetus for us. We said, we basically said, hey, I think we can do something that's better. I don't think what Istio is doing is right. It's definitely better than like the current version of Linkerd, but it's not, there's a lot more we can do here. And Rust, the language at that time, was just starting to become something that it felt like we could build a serious project off of. So that gave us all the energy to say, okay, you know what, let's do this right. Let's make a service mesh that actually is really fast, really small, really simple, because the other thing was Linkerd, this is now the 1.x version with finagle and all that stuff. It was super complex. It was really powerful, but it was so complex, it had this giant learning curve. And so we don't want to do that either. If we're going to do this right, the service mesh has got to be simple, it's got to be fast, it's got to be secure by default. And I think we can build that using Rust in the data plane and Go in the control plane. And so that's what we started doing, basically. And, we released Linkerd 2.0. This is now in 2018. I think it was, 2018. And then the past couple of years have just been very heavily focused on Linkerd 2.0 and on the Rust ecosystem and kind of everything around that.
Yes. I see that people try to compare the Linkerd story with the Docker, and specifically the Docker Swarm story. The Docker Swarm initially came up, they have a service to service and feature to feature comparison with Kubernetes. And we all know that the Docker Swarm is simpler, flexible, faster, and whatnot. But later down the road, team at Docker realized that you are not competing with the Kubernetes, but with the Google. And it's a kind of scary. And finally, Docker Swarm acquired by Kubernetes, and rest is history. So do you have this thing in mind when competing with the giants like Istio on the Google side and the Lyft side? Because I think these two projects have a similar kind of a story.
Yeah, so a lot of people have said that to us over the years. They said, oh, you're just going to be like Docker Swarm. It was simpler, but Kubernetes won in the end. And I think, so we were worried, but 3 years later, it's like Linkerd is just skyrocketing. So it doesn't feel like it's playing out that way. So I think there's a couple differences. Number one is, I think the magic behind Kubernetes was not actually Google, right? Google had a lot, even open source projects that have failed, that have not gotten adoption, that have been, gross and weird. They've had really good projects, but they've had bad ones, right? It's not like Google has this amazing magic. I think the magic behind Kubernetes, left Google, right? And two of them went to Heptio and now at VMware, and one of them went to Microsoft. I think that was the magic behind Kubernetes. And then number two, I also think that Kubernetes was kind of a special case, right? Like there was like the container orchestrator wars, and it won, and like everything else fell by the wayside. And I was very familiar with Mesos, so like I had kind of a soft spot for Mesos, but whatever, we built Linkerd very heavily focused on Kubernetes. But I think that's rare. If you look at the open source landscape, it's very rare to have one winner like so dominant. Most of the time, you have two or three that are kind of like, equivalent, right? And so the service mesh landscape certainly does not seem to be consolidating. If anything, it just seems to be expanding. So I guess my answer to that is like, yes, I'm aware of that. I don't think that's the right analogy, but it almost doesn't matter. It's like, it's too late. We're 3 years into this. Linkerd is just getting better, right? There's more people coming to Linkerd. In fact, at this point, I'd say most of the people coming to Linkerd are coming from Istio because there's so much Istio marketing. So that's where they learn about the service mesh. And then they're like, oh, this is really complicated. There's got to be something better. And then they end up on Linkerd. So yeah, I don't know. I guess empirically, it doesn't seem to be playing out that way.
Yes, definitely. I think you really heard of that. I think what we talk about here is We all know that the larger company have the larger community and the larger ecosystem, but there's a small startup came up. They have to build the technology and build the community out of that in order to support the project in a long running and smoothing project. And why do you think? Because I think the community is hard at any open source project. So why you think the community is so vital to any open source project?
Well, I think the way that these projects work and the way that a lot of cloud native adoption works it's basically bottom up adoption. The reason why community is so important for the whole cloud native space, not just service mesh, is because this technology is adopted bottom up. It's not adopted top down. So, there are some companies where the salesperson will convince the CIO that they have to use, this thing, and then they order all the engineers to obey and use blah, blah, blah. But that's rare. It's increasingly rare. That was like the old model of software sales. And now the adoption model is bottom up. So an individual engineer says, I want to do this and I want to use this project. And I think this is the right way to solve this. And they'll bring it into their company and then they'll try it. And like, if it doesn't work, then everyone laughs at them and says, well, hopefully not. If it doesn't work, people say, okay, well, we tried it. Let's try something else instead. And if it does work, then it kind of grows, up from there. And so in that world, the engineer, and the community becomes super important because that's your mechanism for educating people about the project, for, getting them to try it. Like everything happens through the community. It doesn't happen through salespeople. And that I think is, I don't know, I was an engineer. I still consider myself an engineer. So I like this model because it makes me very important, right? The engineer now picks does the technology decision making. And that's probably what you want anyways, right? Like you want the engineers, you want the people who are closest to the technology to make the decisions, especially when it comes to operational cost, right? Because everyone likes to play around with cool new projects, right? But when you bring it into your company, it's part of your job. Now you're on call for it. Now you have to debug it. Now you have to wake up at 3 a.m. to figure out what's happening when it's going wrong. So you as an engineer end up becoming very discerning and very attuned to not just like, is this a cool project and is it going to solve problems, but what is the cost to me operating this? What am I going to do? Am I going to have to wake up and like fix this thing? And is it going to be complicated? And I think that's a really healthy pressure for software because naturally, I think software likes to become complex. We all want to build more things. And it takes a lot of discipline and focus to keep it simple. And a lot of what we do on Linkerd is we try and keep it as simple as possible, even though we want to do more. We always want to do more, but there's a cost to doing more. And we can do more. We just have to do it in a really disciplined and focused way that doesn't cause a burden, an unnecessary burden to Linkerd adopters.
Yes, definitely. I think the one thing that I like about the Linkerd community, they always tell people that this is service mesh, this is a Linkerd. It's good for this scenario. If you have that scenario, let's go that far and resolve that issue with the Linkerd and the service mesh. I'm not seeing people saying that Linkerd, go use that for every project. You have to need it. You have to do it. You have to, you have to do it in the right way. I think that's I like about the Linkerd community, and I think the community is so vital because I learned from the other Rancher projects, the cloud native projects. The people build the tool, and the community builds an awesome tool around that wrapper. And like K3S have a K3S app facility on the OpenFaaS, Alex. So I think that community is so vital to everyone. And now I think right now we are traveling from past to present, and now I think for the present time that the Istio and team at Google, instead of being a member of awesome cloud native computing foundation, last year we see the new community just built for purpose to support Istio. And speaking of this new community called Open Usage Common, how do you look at it? And I believe that this also gives the extra boost to Linkerd adoption as well.
Yeah, so I don't know. I thought it was weird. I thought it was weird that they wouldn't just join the CNCF. It's definitely good for Linkerd. There are people who care very heavily about, is it this foundation or is it that foundation? And, I tend to be a little more pragmatic. I think if I personally was choosing between different projects, I would care that it was open source. I would care that there was like a healthy community around it. I don't know that I would really care personally whether it was one foundation or the other, but some people do. For some people, it's a really important thing. And so I don't know. I thought it was weird, but it's great for us. So I guess that's good. And the CNCF has been really good for Linkerd. There was a reason why, even very early in the project, back in 2017, 4 years ago, that's a long time, we donated Linkerd to the CNCF because for us, we wanted it to be a neutral project. We wanted it to be something that, there was no one vendor controlling, right? And like Buoyant spent a lot of its time and energy maintaining Linkerd and improving it and kind of, funding that project. But it doesn't, that's not a rule, right? It's not like in the governance document, it's not like, okay, Buoyant is the only one who's allowed to do X, Y, and Z. It's an open project by design. So it's really important to us. And the way that Buoyant makes money anyways is like not by selling Linkerd, right? Like we've got Buoyant Cloud, which is a SaaS thing, which is super cool, but it's not like Linkerd Enterprise. Linkerd has got to be a first-class project that you can use without paying anyone money. You can use it in production and it'll be fast and safe and simple. That was really important to us. So yeah, I don't know. It made a lot of sense for us to join the CNCF with Linkerd, and that's kind of where we are today.
Yes, definitely. And I think the next question, next obvious question that people came up by, how you still competing with other service mesh vendors like Chatterate, Solo.io, Connect, Kuma Mesh. I think 20 other service mesh is on the horizon right now. And mind you see, at the end of the year, there is 30 of more come up, and we see keep on increasing every day. So it's a kind of a scary story in us living in the world of service mesh right now.
Yeah, I don't know. I think it's silly. I think they should just join Linkerd, right? Like, there's no reason to make your own service mesh, right? You might as well join Linkerd. It's going to be better than anything you can do, and we'd love to have you. So I don't know what it is. I think, part of it is there's a lot of buzz around service mesh. There's a lot of like marketing buzz, and that always makes people feel like, oh, this is a really important thing and I need to have a service mesh. If we don't have one yet, we need to have an offering, right? And I think that's silly. I think we will see consolidation. I don't think we'll really get to 30 different service meshes. I think what will happen is the current set of 12 or 15 or whatever it is will start consolidating. I don't think it'll be down to one. It'll probably be down to 3 or 4 maybe. But yeah, I feel bad for people in this space who are like trying to make sense of, what's going on here, right? Like when you are a service mesh vendor, and I don't consider Buoyant to be a service mesh vendor because we don't sell Linkerd, right? Like we promote it, but we're not trying to, like, if you adopt Linkerd, no money comes to us, right? So we can have a very honest conversation, right? Like that means that it's not a sales conversation. It's like an engineering conversation. Right. So we can have a very honest conversation with you and we can say, hey, Linkerd is good for this and it's not good for that. Right. This is just what you were saying before. Right. We're not saying, oh, Linkerd solves all things for all people. Right. That's a sales conversation. So we have an engineering conversation, but a lot of the service mesh space, it is sales conversations. And that makes things doubly confusing because everyone is saying, if you're a service mesh vendor, you're saying my service mesh solves all problems for all people. Of course, like that's how you make money. You have to say that. So for you to come into this service mesh space and try to make sense of it, there's so much noise. There's so much noise. And I think it takes effort to cut through that noise. And that I think is a pity. Like I think that's a real detriment to the cloud native space. That is so confusing to know what to do. Yeah, and we try and like cut through that noise. We try and have a really honest, authentic, engineering focused conversation about Linkerd. But, our voice is only so loud, right? There's a lot of other people shouting.
Yes, definitely. I think you heard a very good word that is right around. There's a lot of noise, but compared to, I think we see that in the 2020, compared to now, is a service mesh is a less noisy compared to 2020, and 2021 is compared to the less noisy. And I think that you heard good things that it's keep on creating the noises, but it's that's shut down, and hopefully we might see a lot of 20 to shrink down to 3 or 4 service meshes, and some the eternal body can operate over it, like the.
Yeah, I think that'll make people's lives a little easier, And ultimately, what we want out of this is for the service mesh to become boring. Like we don't want it to be this super complicated thing that we have to worry about, and then we have to like hire a team to go manage and all that stuff. Like that's not what we want. It's not that important. Service mesh is not that important, right? Like Kubernetes is a big deal, right? Like you have to, if you're adopting Kubernetes, you need to have experts who understand Kubernetes. But I don't think you really need that for the service mesh. Honestly, I don't think you need a service mesh team. And I don't like that idea or that meme that you need a team of experts just to operate your service mesh. Everything we do in Linkerd, and Buoyant Cloud is to fight against that. So a lot of what we do in Buoyant Cloud is basically driving towards a point where we can operate the service mesh for you, right? Where you can have a turnkey service mesh. You just add it and Buoyant Cloud manages it and does upgrades and installs and all that stuff, right? And that I think is a really nice future, because then you really don't have to care. And you add it, and it just, the management component and the operational component gets taken care of for you too.
Yes, definitely. I think that's, you spoke in the right word. That is, I think a lot of the Twitter side, I see the developer are tweeting that they are run the Linkerd service mesh, and they really feel proud about it, that it's spun up in a 2 or 3 minute, and they compared to some other service meshes. So that's, I think, a right word to choose. And I think the next question is really important for me, and I think people who are listening to us, and they are building some open source tool around cloud native technology. How your experience of building open source software, and making a business out of that?
Yeah, it's complicated. It's complicated. I think for us, it's especially complicated because, the competitive landscape is so crazy, and so it takes discipline and it takes focus for us to stay true to our message and not to get distracted by, there's a crowd of people yelling about WASM over here. Okay, don't worry, stay focused. And there's a crowd of people yelling about eBPF. Okay, stay focused. There's a crowd of people yelling about, I don't know, something else. It'll be something else tomorrow. It takes discipline and it takes focus to stay true to kind of the value that you're trying to provide. So that's one thing. I think the other thing is, for us, what we've tried to do, and I talked a lot about this, I think, in our podcast so far, is we've really tried to have a very honest and authentic conversation with our community and with, the Kubernetes community as a whole, right? And in order to do that, we have avoided, we've basically said we're not going to sell Linkerd directly, right? Because that, like I said, that gets us into a sales conversation rather than an engineering conversation. And what that means is that as a business, you then do have to make money, right? You have to, obviously it's like a business. So in order to do that, you basically have to have a business model or a revenue model that is that's different from selling enterprise versions of your open source software.
Yes, I think
that makes sense.
Yes, definitely. I think it's a conversation that all of the other open source project is keeping out. Some people saying that the GitHub is open source, where people fork it or they downloaded it from that. Everything's crazy about this. Awesome, bro. That is helping so many things. But at the end of the day, making money out of that is quite a very difficult task, a daunting task for some of the open source cloud native project. I keep hearing this all the time, that open source is the future. But people in open source still need sponsorships, vendors, and need to be globally recognized, and the community behind that. and what you should recommend to the open source people? How do they effectively use their open source project in order to raise their family, children, and making a money out of it in a good way?
Yeah, and I think that's really important. Like for a project to be successful, for a large open source project to be successful, there almost has to be an economic component to it, because we're not in the days of open source being purely this like off hours, nights and weekends thing, right? Very few projects can survive that way. Most open source projects, it is someone's job to invest their time and energy doing this, and they need to get paid so that they can support themselves and their family. So there has to be an economic kind of relationship for open source to even make sense. So I think as open source consumers, we also have to recognize that, right? We have to say, you know what, I actually want the project that has a company behind it, because that means this project is going to be around. You know, if that company can make money, then they can continue investing in the project, right? And that's very different from what open source looked like 20 years ago. When I grew up, 30 years ago, when I grew up, you know, it was like Linux was a big open source project, and there wasn't, nowadays it's very different, but at that point it was like, you know, a volunteer project, right? And that was kind of what we were trained. It's like, this is what open source means. We're going to take down Microsoft. You know, we're going to all work together in our nights and weekends to destroy Microsoft. Of course, that's not really how it turned out. And now lots of companies make a lot of money from Linux. But, you know, it is a different open source environment, and the commercial aspect of it is something we need to recognize, right? For that project to be successful, for Linkerd to be successful, Buoyant needs to be successful. So like the two things are kind of intertwined, you know, in a way that, we need to recognize, but also it has to be done the right way. You know, like I think the model, the other model that doesn't really make that much sense anymore is the open core model. Frankly, I just don't, you know, this would be us selling Linkerd Enterprise, right? Like, and withholding features and stuff like that. Like, that doesn't feel right for a modern open source project, you know, so we've avoided that as well. So it's complicated. That's what I started with, and that's what I'm going to end with. It's complicated.
Yeah, yes, definitely. I think we have, that's really important conversation to, I think, everyone listening to us, because everyone creating tools around cloud native technologies, and they're looking ways to earn money around that, because that's a vital part of living in the open source and raise their family and children. That's really important to everyone.
Right.
And
right. And building something is always fun and exciting, but then you're maintaining it and like dealing with bug reports and accepting PRs and you know, like integrating with other things. Like at some point it moves from fun to work, right? And so the volunteer kind of mechanics is, you know, you can start out that way, but it's hard to really sustain that. It's really hard.
Yes. I think if we heard a lot about open source and these kind of things, now start some technical discussion around service mesh. So at what point should you think teams should consider to look at the service mesh adoption?
Yeah, so I would say if you are adopting Kubernetes, that's got to be the first requirement. I think, you know, unless you have some very specific, you know, other stuff going on, basically the cost of a service mesh on Kubernetes is like this, and the cost of a service mesh in any other situation is like super high, right? Because like I mentioned early on, Kubernetes solves a lot of the deploy time challenges. So if you are adopting Kubernetes, if you are writing microservices on Kubernetes, you know, which most people are, I don't know, I guess there's some people who are lifting and shifting on Kubernetes. We'll set them aside. I've got my own opinion about that. So if you are building a multi-service application on Kubernetes, and if that application is like kind of a transactional application or something that is like request response oriented, so it's an API that's serving web requests or, you know, serving client requests, or it's you know, some kind of financial system, something where like, you know, you get a call and you have to respond to that call in an amount of time, right? Then you need a service mesh. I think it's that simple. I think it's that simple, because if you don't have that, then you are going to start building all this stuff in the application yourself. You're going to start, you know, either you're not going to have these features, or you're going to have to do them in the application, and that's really going to slow you down. There's no reason to do that. You know, you can install Linkerd in 5 minutes, and we can kind of solve a lot of this for you. So yeah, Kubernetes, microservices, transactional kind of system. I think that's really it. And it doesn't matter what industry you're in or what vertical you're in. You know, we have Linkerd adopters who are in retail. You know, we have like grocery stores and like Nordstrom and stuff. We've got Linkerd adopters who are doing financial transactions. We've got Linkerd adopters who are basically build giant video game like CDN kind of things. You know, the vertical doesn't really matter. We've got people who are using it to like fight COVID, you know, like the vertical doesn't matter. It's really more about like, what's the tech stack that you're building on top of?
Yes, definitely. And I think traditional question that everywhere you go for the podcast is game of the people mind. I tried to ask you as well, why do you use Rust instead of Envoy? And that's, I think, a traditional question everywhere you go and people talk about to you. Why you choose that route?
Why Rust instead of?
Yes,
instead
Envoy. Envoy is.
Oh, Envoy. Oh, yeah. Yeah, so I actually wrote a long blog post called like why Linkerd doesn't use Envoy.
Yes.
And I felt a little bad writing that post because Envoy is a great project and like there's a lot of projects that Linkerd doesn't use. And I don't write these blog posts about like why Linkerd doesn't use
JavaScript,
you know, jQuery or whatever, right? But people kept asking that question over and over again. And so basically it comes down to a couple different things. Number one, Envoy is a generic proxy, right? It's like a Swiss Army knife. You can use it for any number of things. You can use it for a service mesh. You can use it for ingress. You can use it for like some giant cluster, you know, in the middle. You can do anything with it. But because of that, it means, first of all, it means that Envoy is pretty complex. Actually, it means it's really complex. And what we saw, one of the things that we saw with Istio that I really didn't like is that becoming an expert at Istio requires becoming an expert at Envoy, right? If you look in the Istio like set of issues and you search, you know, open issues and you just search for Envoy, it's all over the place. So you have to learn how to operate Envoy, which is complicated. It's a general purpose proxy, which means like, you know, Nginx and Apache, you have to develop operational expertise. And I didn't want that. We didn't want that for Linkerd, right? So we felt like the service mesh, you know, the proxy should be an implementation detail. It should be something that you don't really care about. So we had to avoid all that complexity. The other thing that drove us to building Linkerd 2 proxy was basically efficiency, right? By not having to do all that stuff, Linkerd's proxy can be incredibly efficient and incredibly small. And we're going to release some benchmarks soon and show you just how big of a difference it makes. But it's basically an order of magnitude difference in CPU consumption and memory consumption. So that's huge, right? Again, if you have 1,000 proxies, and those proxies take 150 megs versus 15 megs, or they take, you know, 100 millicores versus 10 millicores, that's a huge difference to you, right? That proxy is the thing that scales out. And then the third thing was the security aspect, right? I don't believe that modern system software, especially software that interacts with the network, that has input, should be written in C or C++ anymore. I think we're beyond that as an industry. We have Rust. Rust isn't perfect. There's all sorts of things that are horrible, right? But there's no reason why we should be writing software that is vulnerable to buffer overflow exploits or to CVEs or to like, you know, any of these things that we know happen all the time. There's no way for you to write secure C++ code. It's just like, it's impossible. So why are we doing that? We need to move beyond that as an industry, and we need to build our software in a way like that's not a thing that we waste our precious, you know, life cycles or hours of our day on. So those three things combined basically meant we should build a specific proxy, you know, custom to the service mesh, just does what it needs to do, very fast, very efficient, safe and secure from kind of the bottom up. And that all led to Linkerd's proxy, which is just called like Linkerd 2-proxy. It doesn't even have a fancy name, right? It's not a general purpose thing. It's a thing that just runs in a pod, and you, as a Linkerd operator, you don't need to understand it. You don't need to know how to operate it. You don't need to read the like proxy manual, right? Like it just works, and that's what you want, right? That's what you want. So we don't even really call it a proxy. We call it a micro proxy, because what it's doing is like such a tiny fraction of what a real proxy does. You know, Envoy can do a lot of stuff. Linkerd proxy can do like one thing, you know? So it's not even a proxy, it's like a micro proxy.
Yes,
so that's a long answer again to a very short question.
No, it's really explained a lot to me, because when I first used the Linkerd, and it's spun up in a very smaller amount of time, and somebody said to me that, you know, it's happening the control plane, the data plane. That's it. What are you telling me? I don't even consider these kind of things. It's so fast. What happening behind this? It doesn't need to care about that. So I think what end up William saying is, in order to build a simpler and flexible and faster system, you have to do the choose the route and do solve the problems that is really you need to solve. Don't think about those challenges that you don't need to solve it on a day basis. We know that the Envoy are doing some kind of a tremendous amount of things, but not everybody needed that problem day to day. So I think that's a really adopted point of Linkerd that's spun up, not needed any cluster operator response, PhD. You don't need any, like what we said in the Kubernetes landscape. You have to run a Kubernetes file. You need a PhD in YAML, but you don't need a PhD in Envoy proxy. There's another proxy that's doing simpler things, and you don't need to learn that. Just fix those problems that you need to solve around that.
And you know, what's funny is Envoy actually is used with Linkerd a whole lot, right? Almost every ingress that people are combining with Linkerd, whether it's Ambassador or, Emissary, it's now called, or something else, like it's Envoy under the hood, and that's fine. You know, that's a great use case for Envoy. I just don't think it's a sidecar for a Kubernetes service mesh. It's the right choice. But you know, read my blog post and then look at the benchmarks, and you know, like that, you'll see what we're talking about. And then talk to any Linkerd user and ask them how much they have to understand about Linkerd proxy, versus talk to an Istio user, ask them how much they have to understand about Envoy. Right? It's a big difference.
Yes, definitely. And I think the next question is, do you think what the role of SMIs are? Because people are talking about the service mesh interface, and I think it's a kind of a very interesting question to ask the vendors for that. Do you choose that route for going for the SMIs way, and what benefits it brings to you if you choose that route?
Yeah, so I have kind of a mixed relationship with SMI. We were early, you know, kind of very heavily involved with the project early on. And if you look at the SMI GitHub, you know, it's Linkerd people are like the #1 contributor to SMI. And what SMI gave us, which I thought was awesome, was the ability for tools like Flagger to be built on top of SMI, which is great because that meant you can use Flagger and Linkerd together instead of, you know, building something on top of Istio and then something on top of Linkerd and then on top of something else. So that was really good. And I was excited, but the rest of that tooling ecosystem hasn't really developed. You know, Flagger is awesome, and a lot of people are using it, but there aren't that many other tools that are kind of like built like that. So, you know, there hasn't been that much pressure on the Linkerd side to then fill out the rest of those APIs. And then Linkerd users have never asked us for it. They've never really seemed to care, you know? So that's another thing that's like, okay, it's on the roadmap. You know, Linkerd has like partial SMI support. Filling out the rest of it is on the roadmap, but it keeps getting deprioritized because no one is really asking for it. So that's kind of where I am. Like, you know, it's kind of an empirical approach. If a lot of people were asking for SMI and there was a lot of pressure and it was really important, then we'd be, you know, probably fleshing out more of the API, but they're not. So that's where we are.
Yeah, and I think can you explain to audience as well what SMIs is, because it's interesting to know how you define it. I see people defining some other way that you're migrating from service mesh to another service mesh, or people saying that if you migrate to another service mesh using SMI, the Linkerd don't have that Istio features in it, and Istio don't have some Linkerd feature in it. So what the purpose of SMIs are then?
Yeah, so it stands for Service Mesh Interface. So it's a set of APIs that are meant to abstract kind of the functionality of a service mesh. So yes, I think in principle, you could, if all the service meshes were SMI compliant, you could then say, okay, I can swap one out with the other. But like, I don't think in practice that's really true, right? Because the operational cost is totally different. It's totally different for Linkerd versus Istio versus some of the other meshes, right? So it's not like, you're making an API over Kubernetes and Mesos and like swapping one out for the other, right? It's like very, very different systems under the hood. So I don't think that's really like a practical thing that can be done. What's more interesting to me, what I think could be more valuable, is a tooling ecosystem, right? Like we can build tools on top of all service meshes instead of on top of just one service mesh. But again, I haven't seen that develop yet. Beyond Flagger, I really haven't seen a lot that's using that. So that's kind of my hope for SMI in the future, is like that's where things develop. But I don't think it'll really be, oh, you can swap your service mesh out, as an implementation detail. I don't think it'll be that simple.
And when so last two question, how can attack vector change when using a service mesh?
How can the attack vectors change? I'm not, gosh. So I don't think I'm going to have a great answer for you. Service mesh, like kind of the big security feature is MTLS, right? And MTLS is great, right? And what it gives you is validation of identity on both sides of the connection. And it gives you confidentiality, right? So like no one listening in can like decrypt that connection. But if you look at kind of the bigger landscape of like, I'm running a service mesh on top of Kubernetes, and and I have a CI pipeline that's like powering that, and so on. Like, communication between pods and the cluster it's not a huge attack vector. In order to get there, you would probably be able to just access the host directly, So I think the broader security concerns that the service mesh really addresses are kind of minor. I mean, they're good to have, and a lot of people adopt Linkerd for TLS, for MTLS. You might as well. It's easy. It costs you nothing, other than running a service mesh, which, it's non-trivial. Like, MTLS works kind of out of the box. And in fact, in Linkerd is on by default. So the moment you install Linkerd and you mesh your pods, MTLSing the connection. And that helps with regulatory compliance, But I think if you look at my personal opinion is if you look at the bigger security picture of like the context around running a service mesh, you're going to have other things you're going to worry about, that are much more important than securing pod-to-pod communication with MTLS. That's like 5% of the problem. And the other 95%, the service mesh can't really help with.
Yes, definitely. I think what the people confuse about the service mesh, that they say pod-to-pod communication are encrypted, but they underestimate that securing the cluster is one thing, and then securing application on top of that cluster is one thing, and then securing the container that's running the application is one thing. So you are just securing the 5% of their security, but what is 95% other things happening there? Because containers.
Yeah, that's right. Yeah. See, if this was a sales conversation, I would be saying, oh, it's critical to all security. You cannot be secure unless you have a service mesh. Linkerd is the only way you'll ever be secure. But it's not, right? We're having an engineering conversation.
Yes.
So the other thing I'll say is that what I think MTLS also helps with is preventing mistakes, preventing developer mistakes or operator mistakes where you like deploy the wrong thing. And that actually is probably more valuable than the little attack vector that it protects against. So there are good reasons to do it. I just think if you're analyzing, the attack surface area, service mesh is going to solve a small portion of it. Not zero, but not huge.
Yes. And before I say you what's the future for the service mesh here Linkerd, the next question that is always people talk about to me answering this question. There is common issues raised when adopting a service mesh, including a number of containers and latency. And that is, I think, everyone need to know the number of containers and the latency. How you respond to these comments when people talk about these things.
So number of containers, I don't quite get. Is that like how many containers
It's mean
the
that
service mesh introduces?
it's mean the proxies. Every application has every application a pod, and then pod has to be another sidecar in it. Is there people are saying how to run, how many sidecar we needed if we have 10,000 of microservices or 20,000 microservices? Do we need have 10,000 sidecars? And about talking about the latency as well.
Yeah. So every pod, I think you described it right. Every pod that you want to add to the service mesh needs to have its proxy sidecar container running. And in fact, I think we introduced technically 2 containers, because there's an init container that spins up and then terminates, and then there's a proxy container itself. So you're going to have a lot of extra containers. Hopefully you're not paying per container, but maybe you are. And more importantly, though, is that one of those containers is going to have the proxy, and the proxy is going to be doing stuff, right? So it's going to be consuming CPU, it's going to be consuming memory, and it's going to be adding latency to every call. In fact, if A calls B, calls C, there's 2 hops between A and B. Like there's a proxy on A and there's a proxy on B. And then there's another 2 hops, proxy B, proxy C. So you've added 4 proxies to this 3-step call. So that's all a cost, right? That all introduces cost to your system. And you can, I think that is what you're going to pay. That's like the resource cost. That and the operational cost are what you're going to pay to adopt a service mesh. And then you'll get some value out of it, right? You'll get the security and reliability and observability. So how do you think about those costs? Well, I don't know. They're not going to be 0, right? And in Linkerd, we focus very heavily on reducing those costs, right? So we make the operational complexity, which is the most important one, we try and reduce that by making Linkerd simple, by reducing our usage of CRDs, by making it easy to inspect the different parts of the control plane and understand what they're doing. In fact, we run the control plane on the data plane. So all the tools we give you to understand your applications, you can also use to understand Linkerd itself. So that's the operational cost. And then the resource cost, we talked about this in the proxy. This is why we built this micro proxy that uses as little memory and as little CPU as possible and introduces as little latency as possible. Those are all ways to reduce that cost. And I think that's really important because the data plane is the thing that scales. So if you have 10,000 pods, you can have 10,000 proxies. And again, if those proxies are 150 megs versus 15 megs, that's a big, big difference in the cost of running a service mesh.
Yes, and I think last question before we go to the what next for the service mesh in Linkerd is I see every time we're talking about the cloud and AWS, Azure, and GK side of things. We see last time Amazon announces some managed services like Prometheus open source managed services. Do you think if in the future some cloud or some AWS side or GK or other side, some has kind of the managed service for Linkerd in the cloud? If that they do it, how you look at these things?
I think that'd be great. I think they should do that. Yeah, I think if we were selling Linkerd Enterprise, I'd be scared of that, right? If we were like trying to control who got to use Linkerd and trying to convince you to use our version rather than Amazon's version, then we'd be scared of that. But that's not what we're doing. It's not what we're doing with Buoyant Cloud. So Amazon, if you're listening, please provide a hosted version of Linkerd. That'd be great. We'd love to see that. Let's talk.
Yes, definitely. Great. And now the final question, what next for the service mesh and Linkerd? That's the future part of service mesh and Linkerd. What's happening this after the 6 month and the whole global, what you see, what your predictions are in this future and coming afterward?
Yeah, so there's 2 big things that we're working on. Number one is, in Linkerd land, we're heavily focused on, for the next few releases, on policy, this idea of policy. And that's, we have MTLS. MTLS gives us identity and encryption, but we need to then turn that into giving you control over which types of communication can happen. Right? So what is allowed? Right now, if you're A and there's B over there and you say, I want to make a connection from A to B, Linkerd makes it happen, like it does its best to make it happen. We need to give you the ability to say, no, A is not allowed to talk to B. So the next couple of releases around Linkerd will be focused around that, as well as some other kind of features that we've been kicking the can down the road on for a while. So, gRPC retries. We're going to roll that into the next release. Why haven't we done it yet? It seemed hard, but now we're going to do it. So, but primarily it's around policy. And then the other thing that we're spending a lot of time working on is more on the Buoyant cloud side, where we want to take over the management of Linkerd for you. So we basically want to say, hey, if you're running Linkerd, we can actually install it for you, right? And we can upgrade it for you, and we can keep you up to date, and we can detect issues. If there's like a proxy that's having a problem, we can deal with it for you. So all of the operational costs for Linkerd, right? It's already as small as we can make it, right? Like it's as simple and straightforward as we can make it, but we can actually make it basically zero for you if you allow us to operate Linkerd for you, right? So that's what Buoyant Cloud is going to be doing. And I think that will get us to the point where the service mesh really is boring, right? Which is what we want. You actually don't really care, right? You just press a button and it's working. And then you as the SRE or as a platform owner, you can focus on what you're trying to do, your actual job, which is not operating a service mesh, but which is building out the platform for your developers. The developers can focus on their job, which is not worrying about the service mesh, but it's building out business logic, and everyone's happy. So I'm really excited about that. I think that's going to make a big, big difference to everyone who's trying to adopt the service mesh.
Yes, and before I let you go, when the COVID is finally over, what you do is to kind of jump, or you go for the traveling, and what you should do if the COVID finally goes away, and should you start traveling, or what kind of activities you do?
Oh, you should install Linkerd if you haven't already. I'll tell you personally, I would love to travel. I'd love to do that again. We've got a lot of family, I've got kids. The kids haven't seen their grandparents for a long time. So I think it's, for me personally, it comes down to visiting family and being together with people that you love. I think that's the thing that has been hardest about COVID for a lot of people, has been not being able to have that kind of in-person connection. So that's what I'm looking forward to.
Yes. Thank you, William. I think it's a pleasure talking to you. It's been working with Linkerd and spinning up cluster every day, and I talked to the man who behind that energy and behind that sport. It's a pleasure talking to you. You've done a good hearing your thoughts about Linkerd and service meshes, and hopefully everybody will learn, who listen to this podcast, will learn a lot of good things, how you do open source, we talk about the present, past, future of Linkerd, and I think get involved with the community. That's the best way to know what's happening elsewhere. And if you need some more issues, these kind of things, now I think Linkerd have the Discord channel, Slack channel, we have a Twitter, everybody tweeting about what I have deployed this cluster, and people are answering those questions. I think it's a very wonderful community. And the one thing that I like about it, they always tell you, we are good at this one things, and we are not doing these kind of things. That is missing in other part of the communities, and that's the person behind William Morgan, I think, is keeping this positive energy behind the super cool project. I hope to get people, it's going to be very popular in the near future, and I hope William Morgan accomplish all his goals with this open source tool in the near future. Thank you, William. I really appreciated your time, sharing your knowledge in Cloud FM podcast.
Thank you so much for having me, Simon, and great set of questions. It was great to be here.
Bye-bye.
Hey everybody, if you want to keep up what's going on in the cloud native ecosystem, we have a weekly podcast show on YouTube and SoundCloud by the name of Cloud Native Islamabad. You can listen for free every single week. We try to find cloud and cloud native experts, share updates on cloud native best practices, cloud native real-world use cases, cloud native deployment patterns, cloud native deployment strategies. Topics include AKS on Azure, EKS on AWS, GKE on GCP, cloud native architectures, cloud native application developments, containerizing application DevOps and automation, cloud native certification strategies, cloud native career tips, and more. So if that sounds awesome to you, head over to the SoundCloud and YouTube and subscribe to Cloud Native Islamabad.